Now we're going to look at the process of drawing your own graph of sine and cosine functions with and without transformations on them. So starting with the graph of y equals sine of x, we're going to be using our unit circle to actually plot these points on the x and y axis. So the x values are going to be the radian measurements as you go around the unit circle, and the y values will be the y coordinates. Now I've listed here the most important ones that we use for graphing, but you can actually fill in all of the other ones if you want, like the pi over 6, pi over 4, and pi over 3 radian measurements. I'll show you the process for doing this on the unit circle next. So the way I came up with those points is by looking at the unit circle and starting off with the angle measurement for the x-coordinate and the y-coordinate on the unit circle for the y-coordinate. So the point 0, 0 is on that table that I gave you. Now I skipped showing pi over 6 1/2 and pi over 4 square root of 2 over 2 and pi over 3 square root of 3 over 2 because these are hard points to actually graph on an x and a y axis just because these are very difficult decimal values to place somewhere. But the y values of 0 and then up here at this one, pi over 2, 1 is another one of the points on the table of values I gave you. And then I skipped these three again because those y coordinates are harder to plot. And I came to pi, 0, and then I continued doing that around. So basically I only plot the points that are on the x and the y axis. So the last one would be the 3 pi over 2 and -1. So that's where these numbers come from, and they're basically the starting point for any of the graphs we do with the sine of x function. If you're just doing sine of x, then these are the points that you plot, but soon we'll be using them and shifting them up, down, left, or right, or stretching out some of the values on them. For your x-axis, instead of writing the tick marks as 1, 2, 3, 4, 5, we use our numbers as pi over 2, pi, 3 pi over 2, 2 pi. So we use the angles going around the unit circle instead, and it is helpful to know that those numbers do have decimal values. Since pi is equal to 3.14, then pi over 2 is equal to half of that, so 1.57, and you could keep calculating the decimals for 3 pi over 2, 2 pi, and then keep going all the way around like that. So in case your x-axis isn't marked off with these easier to use numbers for graphing sine and cosine, you can still place the points as long as you know the decimal value instead. So this is the graph you end up with from the table of values I gave you on the last slide, but now we're going to learn how to actually stretch some of those points around and shift them using our transformation rules. Basically, there are 4 different numbers that can be added onto the sine function. If you have a number out front being multiplied by sine, this is the number that will indicate the vertical stretching or shrinking of the graph. Math-wise, all you need to do is take that number and multiply it by your y-coordinates. So if you look at the y-coordinates I had in the last slide, we talked about the point 0, 0, pi over 2, 1, pi 0, 3 pi over 2, -1, and 2 pi 0. And then that pattern just kind of kept extending in the opposite direction. Basically, it hits the lowest point, and then the next tick mark hits the middle point, next tick mark hits the top. So it would continue doing that all the way around the graph, down to the lowest points, the minimums, back to the middle height, up to the highest point, the maximum, back to the middle. It would keep doing that forever. So if you have a number a, like let's pretend it's a 2 for a second, what you would do is you would take all of the y-coordinates and multiply them by 2. So this is the point 0, 0. If you multiply the y-coordinate 0 by 2, it's still 0. But for out here, we have a y-coordinate of 1. So if you multiply that by 2, you ended up at this location. So the graph would be taller. It would be twice as tall. But then at the 0 values, it would still be passing through right there. And then -1 times 2 would go down to -2. And then it would continue back up, etc. The next value I'm going to look at is the d value. If you see a number being added or subtracted and there aren't any parentheses that it's inside of, then this number is affecting your vertical shift. So it's how much you move the graph up or down. So whatever the number is, you would add it to the y-coordinates. So let's pretend that this is 2. Then for each y-coordinate, this is a y-coordinate of 0, for example. If you add 2 to that, it moves it up 2 spaces. This one has a y-coordinate of 1. So if you move it up 2, it would actually go off of my grid in this case, and it would go up to a height of 3. And then a point like this one, which is at a y value of -1, if you add 2, that would end up at a height of 1. So your entire graph would end up shifted higher, just like this. Now these next 2 rules are a little bit trickier. The ones that are inside of the parentheses, now technically they don't need parentheses if all you have is a number being multiplied by x. The number being multiplied by x will be b either way. But these always go backwards from what people expect. So when you see a positive number inside of the parentheses being added, it's actually going to go the opposite direction. You'll be subtracting instead. And if you see a number being multiplied by x or inside of the parentheses, if it says 2 times, it's actually going to be treated as like a 1/2. It's the reciprocal, which is why I said to subtract or divide the number instead. So these two numbers are the opposite, and that's usually one of the most common sources of confusion for students on this section. So first we'll do the horizontal shift case. Now usually you don't have a number in both the C and the B spots. Usually it's just the number here, and the number that's being multiplied by x is 1. So when you do C divided by 1, it's just C. But if you do have a number in both spots, be careful. You need to take the C value and divide it by the B value to figure out how much to go left or right. But for a quick example, let's pretend that this number was pi over 2 and that B was equal to 1, in which case it doesn't matter. So having a pi over 2 being added to the x's, it should be inside of parentheses to indicate that it's to the x value and not outside of the parentheses for vertical motion. This is going to shift the graph left to right, but I need to subtract whatever that number is. So since I got a positive pi over 2, if I subtract pi over 2, that's going to take each coordinate I have and subtract that number from the x value. Will have the same effect of moving it to the left that amount. So the point that was here moves to here. The point that was at an x value of pi over 2, if you subtract pi over 2, that ends up with an x value of 0. And then pi ends up at pi over 2, etc. So you should end up with a graph that has shifted to the left by whatever amount they put on there. So positives go left, negatives go right for the number inside parentheses. The last number we're going to look at is the B value. This is the number that's inside of parentheses, or if you don't have a C, they don't need to use parentheses for this. It's the number that's directly being multiplied by x. So let's pretend it was 2 for a second. Now this number is backwards from what you expect, so multiplying x by 2 does not double the width of the sine curve. It in fact has the opposite effect. It's going to cut the length in half. So basically you need to use that number and divide your x coordinates by it. So in this case, if I had the x coordinate of pi, for example, if I divide pi by 2, then this point needs to actually happen over here instead. And this point that was happening at pi over 2 now happens at half of that, which is pi over 4. And then 2 pi ends up happening at pi. So basically I'm taking each of the points I have on here and I am dividing them by 2, which has the effect of making the graph half as wide. So I end up going through that full motion of starting from the origin, going up to the top, down to the bottom, and then back to the middle again. It did that in a length of pi instead of over this longer length of 2 pi. And vice versa. If you had 1/2 for the number being multiplied by x, it would actually double everything out. So take whatever number is there and divide your x coordinates from that table I gave you on the previous slide, or graphically move everything a distance of 1/2 towards the origin. So here's an example of the kind of problem you'll have on assignments. One of the most important things to do first is to set up your scale. Now, here in the beginning, the horizontal scale I recommend is setting pi over 2, pi, 3 pi over 2, and 2 pi. This is the horizontal scale I use for 90% of the problems. Now, I like to use my grid and make that 2 tick marks away so that if I do have to do something by cutting lengths in half, for example, I can still hit that pi over 4 value if needed. Or if I have a shift left or right, an amount of pi over 4, then it's still there. So this is the scale I use for 90% of the problems. I'll talk about the other scale I use in a different video, but we also want to do the vertical scale. So always just take a quick glance at your problem and make sure that there's not going to be too much doubling of the heights or shifting things up or down too far. In this case, I can see that my whole graph is going to be moved up a unit of 1 and the heights are going to be cut in half. So I'm going to make 2 tick marks equal to 1, which means this will be 2 up here, and then this would be -1 and -2 going down. And that way I can still do heights of 1/2 on my scale, since I see some heights getting cut in half, and just adding 1 shouldn't push anything off of the top of my image here. So I filled in the starting table of values from the earlier slide just so I could use these for reference. Especially here in the beginning, I recommend that you start off by lightly plotting those dots somewhere on your graph. So 0, 0, pi over 2, 1, pi 0, 3 pi over 2, -1, and 2 pi 0. This is where the sine curve lands if there aren't any transformations on it. Now for this particular problem, I have 2 transformations being applied. One of them is the a value equals 1/2. That means I'm going to need to multiply all of my y coordinates by 1/2. Second, I have a d value of 1, so that means everything is going to be shifted up 1 unit. So these are both operations that are performed on the y coordinates, and I did have a note on the last slide about how when you're performing transformations in the same direction, since these are both vertical, then make sure you follow order of operations. So I have to do the multiplying before I do the adding step. So one of the points I have is right here with a y-coordinate of 0. If you multiply 0 by 1/2, that's still 0, but then I'm going to move it up 1 and draw my dot here instead. So this is going to be the dot for my final graph. Next, the graph for pi over 2 starts at a height of 1, but I'm going to multiply that by 1/2, which is a height of 1/2, and then I'm going to add 1, which would be 1.5. So it's going to land up here. Next dot would have been at a height of 0, multiplying by 1/2 is still 0, adding 1 is 1. And then this 3 pi over 2 dot, -1, my y-coordinate's -1. So if I multiply that by 1/2, that's -1/2. And then if I add 1, I land at +1/2. Now after you get a few dots placed, once you see the highest, middle, and lowest points on your graph, you can actually just keep extending the pattern from there. Because I know at the next tick mark, since it's the lowest it ever hits, it should bounce back up to the middle height, and then back to the highest, and then back to the middle, and back to the lowest, etc. But that side's done. And then if I was going back in this direction, this is the maximum, the middle of the graph. Next tick mark, it would be at the lowest point, the minimum, and it would go back to the middle height, back to the max, and then it would bounce again back to the middle. So these are the dots I'm actually going to use for my final graph of 1/2 sine of x plus 1. So ignore the red dots I drew originally for where sine normally lands. That's the final answer for this one. So eventually, hopefully, you won't have to draw those original sine dots out, but they are helpful, especially in the beginning while you're learning this, for seeing what to do to transform the graph. I'm going to go a bit faster through the cosine rules because they're actually the same as sine's rules. It's just that we have different starting points. The x values for our starting points are still the radian measurements, so that's the exact same. The only new thing is that the y coordinates for our points that we're plotting here will now be the x coordinates off of the unit circle. So basically for this one, I'm using the angle measurement and I'm using the first number in each ordered pair. So my first point is 0, 1. I'm skipping those and I'm going to pi over 2, 0. And then I'm skipping the next 3 and I'm going to pi -1. Cosine is based on the x coordinates. That's why I'm using the x coordinates from each ordered pair on the unit circle. So that's where that table of values is coming from. Here you can see what the basic cosine graph looks like without any transformations. So you have the point 0, 1, pi over 2, 0, pi -1, etc. But everything else is the exact same. We've just changed this to say cosine instead of sine. So as far as whether you multiply or add to the y-coordinate, same rules. You're still doing the opposite operations for the c and the b values inside of parentheses. It still doesn't matter whether you do the horizontal shifting or the vertical shifting first. So you can do the c over b and the b values before you do the a and d ones if you want. But make sure if you have both a multiplication and an addition for the vertical direction, for example, make sure you do the multiplying before the adding. So I've already set up the normal shape of cosine by using the ordered pairs that I gave you in the table in the last slide. And here I've identified that a is -3, b is 1, because I don't see a number being multiplied by x, so I don't have any stretching or shrinking in the horizontal direction. But there is a c value of pi over 2, so this is going to go left pi over 2. And the d value is -1, so I'm going to shift everything down 1. So the trickiest thing is don't forget that this one's backwards from what you expect. So the first point I have is here at 0, 1. If I multiply the y-coordinate for this by -3, it ends up at this location. And then I'm also shifting it down 1 more because of the d value. And then the last thing I'm doing is the horizontal shift to go left pi over 2. So basically this point here ended up all the way down here instead. I'm just following the operations though. The y-coordinate multiplied by -3, subtract 1 more, and then move it to the left a length of pi over 2. So then pick another point. This one has a y-coordinate of 0. If you multiply that by -3, it's still 0. And then you subtract 1, so you get -1. So that's it for the y vertical translations. Then horizontally, I need to move it to the left pi over 2. So it ended up over here. Next point is pi -1. If you multiply -1 by -3, you get +3, and then subtract 1 to hit 2, and move it to the left pi over 2, which is 2 of the little squares according to my scale here. Now, like I said, once you've done a few of the transformations, once you have a lowest, middle, and highest point, you can actually just keep extending from there. So I know at the next tick mark, my graph would go from the maximum back to the middle height, and then next tick mark back to the minimum, and then back to the middle. And on this side, it would go from the minimum to the middle, and then up to the highest point I ever hit, which is 2. and then back to the middle. So this is the graph of -3 times cosine of x plus pi over 2 minus 1. So the best advice I can give you is to start off by writing down what you have for the a, b, c, and d values, and then use the rules I've given you for what to do to the x and y coordinates according to the numbers you have. And then in the beginning, at least, try to start off by drawing the dots without transformations so that you can use those for reference. And that's it. The more you practice this, the better you'll get at it. Thanks, guys.